And magnetic fields are generated by planets because of liquid metallic interiors rapidly rotating. So the Earth has a liquid metallic outer core, and that outer core rapidly rotates due to the Earth's rotation. And so the Earth then generates a magnetic field. Anywhere we have liquid metal rotating quickly, we have a magnetic field. Remember how I said Jupiter rotates once every 10 hours? Well, it has a gigantic layer of liquid metallic hydrogen, one of these amazing superstates of matter where the hydrogen atoms are compacted so closely they behave like a metal. And so Jupiter produces an enormous magnetic field. To get an idea of how magnetic fields span out into space, they actually curve out away from a planet into space and generate magnetic field lines around the planet. When the sun's solar charged particles, the solar wind particles, come and hit that magnetic field, they get excited. They actually travel down the magnetic field lines, excite atmospheric molecules, and when those atmospheric molecules relax back down, the electrons release a color. And that's what actually causes the beautiful auroras. Auroras then are caused by solar wind particles traveling down magnetic field lines, hitting the atmospheric molecules, exciting their electrons, and then when those electrons relax back down, they release a color. So I'm going to demonstrate how a magnetic field operates today with this. For part 6, then, I have a bar magnet, and I've got a little plastic sheet that's going over the top of the bar magnet. And I do that so the magnet doesn't get the iron filings. I've got a container of iron filings here, and it's like an assault shaker here. So I'm going to go ahead and sprinkle some iron filings out for our demonstration purposes. Try to keep it on the plastic sheet here. Okay, and when I distribute out these iron filings in a random shape, they kind of disperse out everywhere. Okay, but when I actually let the magnet, and this is a bar magnet with the north of the bar magnet there, when I actually tap the plastic sheet, a fascinating thing happens. The iron filings line up with the magnetic field of the bar magnet. And so you can see that they're falling into the magnet, but they also have this curved shape. They have a curved shape around the magnet. And so I'm going to kind of disperse out these iron filings, and let's try that again. Okay, when the iron filings are kind of randomly dispersed and we put it on the magnet, first of all, the magnet sucks them in, and second of all, when we tap the plastic sheet, notice how the iron filings line up with the magnetic field of that magnet. Very much so like that does a magnetic field happen around the Earth. Its liquid outer core spinning rapidly with the Earth's rotation causes a magnetic field to be generated, and it extends way out into space. So when you do this with a bar magnet and tap the plastic sheet above, you can see that if I'm going to draw this, I'm going to draw a bar magnet with curving magnetic field lines. They actually exit out the north and come back into the south, like so. Okay, and so you're going to draw what you see here. Planetary interiors. What we're really looking at in this part is the magnetic field of an object, planetary object. And so the Earth, as I talked about, has a liquid outer core made of iron and nickel. And of course, the Earth takes 24 hours to rotate around one complete time. I also explained how Jupiter rotates once every 10 hours, which is pretty quickly, and it has a liquid metallic hydrogen layer. All right, that's, again, one of those extreme forms of nature, kind of an exciting thing where, pictured here, you have hydrogen gas where the molecules would be a little bit more spread out. Hydrogen liquid, the molecules are a little bit closer together, but liquid metallic hydrogen, where the molecules are so close together that the electrons can flow Let's try that again. The electrons can flow freely through the material. And so you get this metal sort of effect. And when you have Jupiter in its deeper layers, there's a lot of overlying pressure of all the weight of the molecules and gravity pushing them down. When you get in the deeper layers of that liquid hydrogen in Jupiter, it's liquid metallic hydrogen. Pretty amazing. And that pressure producing liquid metallic hydrogen also makes it responsible for the big magnetic field, the powerful magnetic field around Jupiter. And so this part is really exploring what would it be like to have planet X, okay? And planet X either be made of material A or material B. And so what I'm going to do is I'm going to spin material A, and material A is liquidy inside, okay? So you would imagine that liquid interior layer. And planetary object B is solid inside. So my questions would be I'm going to spin each of these cans. We're going to see how many rotations they make with the same sort of spin on them. And of course, the difference is going to be that one is liquid inside and one is solid inside. We'll see which one spins faster or more times, I guess. And if the cans above represented the interior planets, which one would produce a magnetic field, A or B? And really, as we're discussing this, we realize that can A probably, because it's liquid, would produce that magnetic field. But let's just do it anyway. Let me show you how it turns out here. So let's spin can A, and we'll see the number of spins. And I'm going to slow this part of the video down so you can see. We'll do a little slow-mo situation here. Ready? Okay, can A is facing this direction. Okay, the same amount of spin now applied to can B. Okay, so obviously can B is having an easier time spinning around more times, so maybe that speed of spin is not slowed down so much with can B. Can A might cause a planet to wobble, as the Earth does on its axis as it rotates. But can A also has that liquid inside, which has a potential to make that liquid metallic interior rapidly rotating to produce a magnetic field. So which would produce a better magnetic field? The liquid one.